This is the 2024 Kickoff show. But before we get into the show, I wanted to put out a hiring call. I'm looking for my next software engineering apprentice, a young .NET programmer to help me directly with my work, building architectural prototypes, figuring out new patterns, tons of coding. I'm looking for a .NET programmer whose hobby is also programming. For the right person, programming isn't work, it's play. And besides a job, I guarantee that you will learn faster than you ever have before. I'll invest in your professional education and we'll work together. You'll report directly to me. And if this sounds interesting to you, then just send me an email or give me a call. Now on with the show.
The Azure DevOps Podcast is a show for developers and DevOps professionals shipping software using Microsoft technologies. Each show brings you hard-hitting interviews with industry experts, innovating better methods, and sharing success stories. Listen on to learn how to increase quality, ship quickly, and operate well. And now your host, Jeffrey Palermo.
Welcome to the show. I'm Jeffrey Palermo, your host for helping you and your teams move fast, deliver quality, and run your software with confidence in Azure, all while using everything that the .NET ecosystem has to offer. The podcast is sponsored by ClearMeasure, a software engineering firm serving companies struggling with past failures of business-critical software projects. You know, they really deliver, establishing high quality, achieving rock-solid stability, and moving at the speed of your business. So when failure is not an option, ClearMeasure guarantees your project will succeed. You can find them at clearmeasure.com. A quick announcement, my architect forums are going strong. Signups for the next session are up. And if you lead a software team and are looking to collaborate with peer architect leaders, then just sign up at the link in the show notes. And for those looking for Programming with Palermo, my video podcast, just search for it in any of the directories and you'll be able to find it. So, welcome to 2024. It's going to be a great year in .NET, in Azure, and with DevOps. And to kick things off, I wanted to review some of the big things that you're going to look for in 2024. And to do that, I'm airing a piece I recorded reviewing the highlights from .NET Conf, looking at it from an architectural perspective. There's so many updates, but in this piece, I interpret the architectural thinking that you'll undergo as you implement the new bits. So, Happy New Year, and I'll roll the piece. All right, let's get into .NET 8 and what all the announcements were. So I'm going to touch on, and if you've vigorously watched all the content from .NET Conf, then you're going to see, some of these slides and visualizations that look pretty familiar. And that's fine because we're going across the announcements and I want to interpret them and tell you how you should think about them and how it's going to potentially change the way you set up your software architecturally. So with .NET 8, there's a lot of history that's come together and some pieces that have finally fallen into place that started with the .NET Core era, where .NET Framework 4.8, they said, you know what, we need .NET to be cross-platform and not just Windows. That was a big thing. So .NET Core was born, but in the process, a lot of things got split. WinForms and WPF were left out of .NET Core initially. And then, of course, .NET 5, it was .NET Core 3, .NET Core 3.1. And then instead of a .NET Core 4, we jumped to just .NET 5 because we had .NET Framework 4.8. We didn't want to do, when I say we, Microsoft, the industry. And so we went to 5, 6, 7, and 8. Now, in the process, everything has come back together, and the only disparity left with what you can't do with .NET 8 and the .NET Core lineage that you might be able to do with .NET Framework comes down to dependencies and libraries. If you're controlling some specific hardware that has an SDK or a library that was built with .NET Framework, and that vendor has not given an SDK or a library to control that hardware with .NET Core, those are the types of things that are going to hold you up. It's dependencies. It's not the type of software. And so all of the modern workloads can be handled with .NET 8. Any type of client, whether it's Windows, Mac, Android, iOS, even the system on a chip, Raspberry Pi, bespoke boards that need to run in an IoT manner. The artificial intelligence is kind of new and expanded from last year. And then, of course, cloud native. And from a developer productivity perspective, we'll touch on what you need to think about from a language perspective. And then .NET 8, they worked on a lot of fundamentals with performance. So performance is improved all around. And we'll talk about one of those that really does impact you. But this has been the focus of .NET 8. All right. So let's touch on Maui, which is the way to create smartphone applications, Mac applications, and then, of course, if you're targeting WinUI. All right. Maui, the biggest change architecturally is the single project system, the single code base. And the second to that is making Blazor hybrid apps a first-class citizen and really targeting that. I'll talk about Blazor in general in just a bit, but with Maui going to a single project system, this is big. This is something that was a little bit more difficult in the past, where you had different projects. Now you can create a Maui application that's a part of an existing Visual Studio application, and it's just another top level project. It's just another project that has a program.cs. In this case, it's Maui program.cs. And so that's big. They've done a lot of work to consolidate it down. And inside the platforms folder, you see iOS, Android, et cetera. And this is what it looks like. So when you think about putting together an application, any of your existing applications, you can just add a Maui project to. Now, you could in the past, but it's clunky and your developers really had to train up. They've simplified it big time. Okay, so this is one thing to consider. Do you have an existing Visual Studio solution with a distributed application, and maybe you have a WinForms WPF client, maybe you have a web application client, and you know what? Yes, you could expose some web services and then have a different Git repository for this Maui application. Certainly you can do that. But if you've said, oh, it's not really worth it, we just want to have a few of these functions for the Maui application. Well, now consider doing a proof of concept, do a feature branch, and allocate a couple days and assign somebody to add a Maui project to your existing Visual Studio application and see what it would take to get your existing application enabled on an iPhone app or enabled on an Android app. Not the whole application, but maybe a few functions where it would be beneficial for whoever uses it to have those functions in their pocket. So that's a big change, a big simplification. And I predict that it'll help a lot of developers who kind of been on the sidelines from a smartphone perspective kind of jump in here because of how simple it's made it. Okay. All right. So that's Maui. All right. So that's an example. I'm not going deep into Maui. I'm not doing demos. That was the nugget of how I think that you should take a consideration and do that proof of concept and the difference that makes the difference. Yes, there's all kinds of API changes. There's all kinds of library nuances and whatnot. But architecturally, this is a big enabler for developers. All right, let's switch to artificial intelligence. So since the Chat GPT came out about a year ago, and multiple GPT technologies have been launched with the large language models, everybody's been talking about it, but it's been chatbots and image generation and generating video, video fakes of all kinds of stuff. But .NET with .NET 8, Azure is also stepping up the game and creating the OpenAI services in Azure. And the big news architecturally is semantic kernel. Now, you might not know what that is. Go on Microsoft Learn to see what that is. But the goal, and my layman's rendition of their vision, is not to create AI applications or GPT application. AI is such an overloaded word. It goes back to 1956 and at Dartmouth College, and the original hypothesis was, you know what? I bet you, here's the hypothesis. I bet you we could select an aspect of human intelligence and describe it so specifically that we could build a machine to imitate it. And you know what? That hypothesis has played out. We are creating machines to imitate a form of human intelligence. But AI is so overloaded. The term is so overloaded. We're calling it AI, but we talked about AI in the 90s. I think AI is for the type of artificial intelligence that doesn't have a better name at the moment. I mean, if you think about it, adaptive cruise control is a type of artificial intelligence. It used to be that only a human could look ahead on the road and modulate the brake and the accelerator so that you kept going forward without hitting the car in front of you. And now, guess what? There's a machine. There's a little computer inside the car that's doing that. That's a form of AI, but we have a better name for it. So we don't call it AI. We call it adaptive cruise control. And so I like to call this latest wave just GPT because that's at least a more specific terminology, generative pre-trained transformer. And of course, it's synonymous with large language models are the enabler of the GPT technology. But the key is that it's pre-trained. Okay. Now, what's out there now and is being actively developed is a combination of GPT and a programming model. And this is interesting. And I think that you should do some architectural prototypes. And this is the vision. And again, this is on the semantic kernel. This image is on the semantic kernel page of Microsoft Learn. The vision is that you have a piece of software, that you have an application, and you create plugins. Think C# class. You create a plugin that can access a certain system, and then you create agents. Think Microsoft class. In the Microsoft world, it's copilots. You know, they're creating all kinds of pseudo smart agents, and they're calling them copilots. And then that sits on top of the Azure services. That's the AI orchestration, which sits on top of the foundational large language models that Microsoft has invested in through their partnership with OpenAI. And it's all running on top of Azure, which is the AI infrastructure and all of the GPU and special AI hardware that they have been installing like crazy in all of the Azure data centers to get it to perform with right scale and the right temperatures and the right electricity usage and whatnot. So how it comes back to us as programmers is this programming model that Microsoft is putting on top of it. Sure, it's interesting to use Bing Chat and Google Bard and these AI programs or these GPT programs that have been put out, but Microsoft is giving us the building blocks so that we can create our own GPT program. Okay. And what it's going to look like is just a regular .NET application with a program.cs. And we're literally just going to call .NET run. And it's going to be a program that spins up our own class. And if you think of the actor model, the actor pattern, then you can imagine how these agents look. And you can give an agent a personality, a focus, and you can interact with that agent. And the agent could be a simple chatbot, or you could give the agent tasks. And then through plugins, it could be as simple as web services to an existing one of your applications or databases, or it could be, interfacing with smart home stuff to just turn on or turn off lights, or it could be, looking up reports on one of your existing software applications. But with with .NET 8 and this era of Azure services, semantic kernel is your architecturally significant concept. Look into that, do some pilots, because now is the time where you can just open up Visual Studio and create create a new project and literally run the application, and you're running your own GPT program. And the agent is the object in your program that you can interact with. And of course, interacting via chat is kind of this era of it. Sending it messages, sending it free text messages, and asking it to do things and asking it to respond. So that's different from Chat GPT and Bing Chat, is that they can only respond. They can't do things. So what you can do here with plugins is you can expose actions to your agent so that your agent can do things. All right. That is significant. All right. Let's move on to cloud native. Big focus on observability through the implementation of OpenTelemetry and their partnership there, and also building in libraries for resiliency and scalability and manageability. When it comes to like resiliency, some of the examples are just auto retries to databases, auto retries to web services. The .NET team is giving libraries that you can use to orchestrate connections to outside systems that will just give you policies out of the box that you can kind of just turn on and not have to think about auto retries or what to do if it fails for 10 times in a row. And you can always implement the circuit breaker pattern on your own, but there's these libraries that are popping up that implement these patterns that have proven beneficial in the cloud world, so that every application developer doesn't have to personally implement the pattern. So that's going to be really great, give you a good time saver. So research and train your people on these new libraries, have them use it, make sure that they're not hand rolling a pattern that you can get for free just by pulling in a NuGet package. So if you're running a team, there's always been the not invented here syndrome, or just out of ignorance, I don't know something exists, and so I hand roll it, or build versus buy, and I elect to build everything myself. Custom code is the most expensive thing that we can do because it's tied directly to developer labor. And so if we select a architectural pattern and we think that's appropriate, then the next decision is asking ourselves, okay, can we get that pattern implemented in a very cost-effective manner? And using a library that's pre-built to implement that pattern, of course, we would want to do that instead of having our own developers on the team hand roll an implementation of that pattern. So look at those libraries, look them up. Some of them, of course, listed on the screen, extensions.resilience. Health checks are another thing that's not new, but with .NET 8, Microsoft is kind of elevating the status of that concept. And if you don't have health checks already in your systems, then the implementation is going to be really, really streamlined. But essentially, you need at least a minimum of one health check class per dependency of your application. And let me give you an example. If you have an application that calls out to a SQL server, well, that's one dependency. If you have it that calls out to a payment processor, 2 dependencies. If you have it call out to, let's say, Twilio for sending a text message, that's 3 dependencies. If you have it call out to a weather service to get the weather, that's always the easy example, right? That's the 4th dependency. You need a minimum of 4 health check classes, because each one of them needs to write just a few lines of code to do a quick round trip across the wire to whatever that dependency is, and make sure it's online, make sure it's happy, make sure we can connect to it, and then come back and report, yes, you're healthy. So we need to know that, okay, SQL Server's online, I can connect to it, it's happy. Twilio, I can get to that. The payment processor, I can get to that. The weather service, yep, I can get to that. And those are 4 health checks, but those together answer the question, after you deploy, and of course on an ongoing basis. Hey, is this application fully online, fully connected, fully operational, fully healthy? And the biggest problem when an application goes down is not that somehow the lines of code in the central memory space start going wonky. No, it's that something outside of the main application process, and oftentimes something outside of the server that it's running on across the network, something has happened where I can't connect to it, or the service on the other side of the wire, something's going on with it. And so health checks are just a library now, extensions.diagnostics.healthchecks.common. And we did some content even implementing it in .NET 7, but it's even simpler now. And so architecturally, there's a big focus on making your software more reliable and more stable when it's running in its target environment. And so these are things that you want to equip your team with and make sure that they're adopting them. Because if you don't, then either they're not going to know about it and not going to do it, or they're not going to know about it and they're going to want to do it, decide to do it, and then they're going to hand roll it themselves. And it's just going to be way too expensive. And it's probably not going to be as good. Okay.
Many thanks to our podcast sponsor, ClearMeasure. ClearMeasure is a software architecture company that empowers clients' development teams to be self-sufficient, moving fast, delivering quality, and running their systems with confidence. Whether starting a new project or developing new technologies or techniques, ClearMeasure sets up your team to deliver world-class results. Learn more at www.clearmeasure.com. ClearMeasure, empowering software delivery.
ClearMeasure is also happy to be a sponsor of the video podcast, Programming with Palermo. Watch, learn, and program alongside Chief Architect Jeffrey Palermo. Videos are added weekly and available on syndicated locations supporting video podcast or by visiting palermo.network. Tune in today.
And there was a question that came up. I just answered it, but I'll say it again. Please give me some examples of these libraries. Where can they be found? They can be found on NuGet, and the names listed on the screen are literally the ones that you want to search NuGet for. All right, good question, though. Always good to be clear on that. Okay, next is containers. All right, lots of talk about containers, but there's some key changes that you need to be aware of. And I'm not going to talk about all the enhancements because you can just watch the content for yourself. But I do want to talk about two things. Okay. The first one is how they're being made smaller. So I'll go to the next image, and you can see from left to right how small the available containers are being made. And originally, when Microsoft started supporting containers, their strategy was bring your own container. It was, hey, we support containers, so give us your container and we'll run it. And then, they realized that, well, developers are great at developing code, but it needs more of a specialty to figure out what size the container should be, not from a computing standpoint, but what should be in the container. Because a container is basically a slice of an operating system. And so the container needs to be designed. And then Microsoft said, you know what? We need to start putting out some images that have like the .NET 7 runtime, the .NET 8 runtime, which, by the way, if you have a .NET 7 application on Azure Container Apps and you're updating it to .NET 8, don't just update it and then deploy and expect it to work. You need to change your Docker file so that you use the .NET 8 image. All right, pro tip, there you go. But Microsoft has said, you know what? We are going to design and maintain our own set of preferred container images for different scenarios. And so they've taken Ubuntu and they've chiseled it down, they've pulled things out and they've trimmed it out, and they've even done a version that is ahead of time compiled runtime for .NET 8. Now, by the way, just a quick aside on AOT, for most developers out there, it's not ready. It's one of the things that you need to keep an eye on. look out for this next year, look out for new announcements, but don't jump on the AOT bandwagon right now. It is still bleeding edge, which means whoever jumps on it is going to bleed a little bit. So for those where the architectural strategy is to use things that are fully stable and fully supported so that you can just focus on your business application, AOT is not ready for you yet. But for any of you who need to be running more things on system as a chip, IoT, smaller, denser data center scenarios, or even just small devices, and then you may want to jump on the AOT bandwagon and just deal with all the dependencies that are not quite there from a ahead of time compilation perspective. And for those who are saying, what the heck is AOT? .NET normally and all the time uses just-in-time compilation from the .NET Intermediate language to the actual native instructions that are running on your particular chipset, whether it's on a Windows box in the Intel x86 or x64 chipset, or whether it's running as a Maui app inside an iPhone and is going to natively just-in-time compile it for that chipset, or your IoT chip. Normally, it's just-in-time compilation, like Raspberry Pi for the ARM chip and whatnot, ARM. Ahead of time compiled is saying, I know that the target device that I'm supporting is x64. Let me ahead of time compile everything directly to x64 instructions instead of letting the x64 device just in time compile it to their instructions, or letting the Raspberry Pi ARM device just in time compile it to ARM. We would ahead of time compile it to the ARM instruction set, and then we would deploy it to the ARM device. Okay. So that's what AOT is. So if you really need that smaller, shorter startup time, all the benefits that go with AOT, well, then you might jump into it. For the rest of us, for the rest of the applications, because all of you will probably have one scenario where AOT is really awesome and you really need to use it. But then we have all kinds of other scenarios where it's just really not going to make a difference for them. It's not going to give us a return on investment. But the Ubuntu chiseled and trim option could be really, really amazing by not using up a lot of our Azure spend running container images that are bigger than they really have to be. So this is going to save us money. Now, Microsoft likes it because they're going to be able to have a higher application density for the same amount of Azure data center capacity. So that's good. Okay. Now, how do you know if AOT is for you? Well, if this next slide gets you excited, you may want to be one of the people that want to jump in and do an architectural pilot on AOT. So look at the size of these bars. You have published set, working set, startup time, and requests per second of a sample web service. And the size of the bar is 100% of the before value. And the next slide is the reduction in that particular metric after native ahead of time compilation in .NET 8. So requests per second in the current form, slightly reduced because they haven't really done optimization yet, but the published size of the application, way down. I mean, like way down. The working set, way down. The startup time, the time it takes the application to start up before it actually starts to execute your code, way down. So if that gets you excited, you may want to do a AOT pilot. All right, let's get into .NET Aspire. This is, again, something that's not quite ready. It's in preview, but it's out there. And they kind of hinted that they're working hard on it and they want to get a GA release sometime in the year 2024. But now that it's all public, all the code is being written out in the open in GitHub, it's not going to be any mystery how far along it is, what the issues are, and when it's going to be ready to actually use in production applications. But the problem that they're trying to solve is that distributed applications, you're kind of on your own for putting all the pieces together. And let me just move to the next screen and let me talk about a few things that they're bundling in as feature sets of Aspire and might get you a little bit distracted architecturally because these are not the most exciting things. These are just some of the features that are interesting to include. Structured logs, this is all open telemetry. And then dependencies, that's the big one, okay? So with .NET Aspire, because they added a model for dependencies, well, now there's a place where we can universally implement open telemetry. All right. So open telemetry is not new. The structured logs, metrics, distributed tracing. They started talking about that more pointedly in the .NET 7 era, and some before that. So that's not new, but they're kind of rolling it up. They're providing a lot more guidance. But the dependencies, this is the big one. This is what you should be honing in on because this is significant. With .NET Aspire, you have a way in code to describe everything that's in your Visual Studio solution. Okay, well, I'll show you what that looks like. And by the way, if you have no idea what .NET Aspire is, go watch some of the videos, go watch some of the demos. But this middle bullet point, express application topology in C#. This one is the biggest significance architecturally. This is the one that actually changes things. It's not just a nice to have, oh, let's make it easier to implement open telemetry, or, oh, let's give you, a dashboard if you're not using Datadog or Application Insights. No, it's the application topology as a code level description. All right, let's finish up with Blazor. So Blazor is the new normal .NET application type. If you're creating a new application, what's it going to be? It's going to be Blazor. It almost doesn't even, well, if it has a UI. If it has a UI, it's going to be Blazor. If it's just behind the scenes processing messages, then it's not. But if it has a UI, it's going to be Blazor. That is smartphone, iPad, Mac, Windows desktop, web, static website. It's going to be Blazor. They've brought everything back together. One of the holdouts was static server rendering, where you might still use ASP.NET MVC for just static websites or use Razor pages. And now that has been brought under the component model of Blazor for static rendering. So there's all kinds of nuances to Blazor. And if you're still not up on Blazor and all its capabilities, Microsoft has a lot of content there, but go to blazortrain.com and watch those 100 plus videos from Carl Franklin describing in detail everything about Blazor. And architecturally, the biggest news and the biggest impact to your team is that you can have one skill set and develop any type of application. That's huge. I think we have probably a decade of lots of people learning JavaScript frameworks for interactive web applications because Microsoft left the door open. They had ASP.NET MVC and they had Ajax, but then there was no resident stateful model, and some really innovative JavaScript frameworks came out. Knockout kind of being the first significant one, and there's of course Angular, React, Vue, and we have lots of flavors and lots of versions of all of those. But one of the first ones, Knockout JS, which by the way, Steve Sanderson built that. And then Steve Sanderson was one of the main leaders in literally building the Azure portal. And he designed the Azure portal with Knockout. He learned a ton about stateful web applications in that project. And then he basically harvested his learnings and created the Blazor component model, taking the lineage and the binding of everything that he had learned at Knockout, doing a major, major software project in the Azure portal, and then saying, you know what? This is the web framework that I really want to use. and then he designed it, and now we're all using it. So regardless of what you're using for web applications, architecturally, I would say start planning for a consolidation to Blazor. The advantages are too great. It's not, hey, I like Blazor versus I like this. No, I'm making an economic argument here. And if you're running a team, you have to think about economics. If you can do all of your software using a single type or a single category of skill set of developer, then you're going to get more productivity out of the entire team. Instead of having to have some number of developers that are deep on the JavaScript stack and all of those libraries, and then others that are deeper on .NET. Now you can have .NET, C# developers, and I am making an assumption. Most developers in today's day and age have gotten fairly strong at HTML and CSS. Okay, given that, and to the extent that assumption is correct in your team, then you've got a core skill set of C#, .NET, HTML. Okay, and throw in some CSS, but if you're weak on that, you can get designers to help you. And then you can build any type of software with the Blazor model. You can run just regular static server rendered server-side websites. You can write SPA applications. You can have entire rich client applications that are launched from a browser. You can run native applications wrapped in a WinForms or WPF shell on the Windows desktop that are every screen is Blazor. You can write little programs that run in a system tray icon in a system tray WPF project type, but whatever screens they pop up are just Blazor. You can write the Maui applications with Blazor. And so now you can write every application type that has a user interface with the same developer skill set, the same programming model, the same design patterns, and largely the same mix of libraries across all of them. That is huge. That is huge. So it's kind of hard to ignore it. And that's the economic argument. That's not I like A versus I like B, or I think this is the nebulous term elegant and this is not. It's really economically, it makes too much sense. And if you know the option is available to you, run to it. And if you have fragmented skill sets, start planning for consolidation. Microsoft has published a lot of upgrade paths to Blazor. That content is out there. It's pretty well known how to move from the older application types to Blazor. All right, we're kind of on the home stretch here. And for those of you, thank you for going long. I don't think we've had any drop-offs, but I'll finish with the language. C#. There's a lot of C# enhancements, but the one that I want to key you on is on line 7, class level parameters. Out of all of them, class level parameters are going to change your game. They are going to eliminate so many constructors and simplify classes and reduce the number of lines of code. And so reduce the scrolling, increase time from opening a class to immediately understanding what you're looking at. And I want to stress that class level parameters do not compile into fields. If you're curious, create a class and compile it, and then decompile the class, or look at the decompiled sources just to get an understanding. Class level parameters do not compile down into private fields. This is a new class member type, and it's not officially a member, but I guess it is. A class level parameter. A class level parameter is available as a parameter to all of the other members. If you're writing code inside of a getter or a setter in a property, you have access to the class level parameter. If you're writing a method, you have access to a parameter. So think about it. You're writing a method, you have access to that method's parameters, but you also have access to the class level parameters. Class level parameters are in scope for any other member, properties, getters, setters, or methods. So this is a new concept. There's so many changes that are like syntactic improvements, but this is a new, a top level new concept in the C# language. We've always had method level parameters. We've never had class level parameters. So this is a new concept. It's gonna impact a lot of code. And that's the one highlight of C# 12 that I really want to call out, because I'm already adopting them. And I think that it makes so much sense to, anytime you're modifying a class proactively, just get rid of that constructor and use class level parameters. Okay, absolute last topic is actually on the SQL Server side, but because the .NET 8 version of Entity Framework made a change and enhancement, it totally unlocks the world of document databases. In the .NET 8 era, architecturally, the problem of figuring out where to store data and how to store data, you're consolidated again. There's a theme I've said multiple times: consolidated, simplify. When we said, you know what, this isn't quite relational data, I don't want to store it as relational. Maybe we reached for Cosmos, maybe we reached for Mongo and used a document database. SQL Server, several versions ago, started natively supporting the JSON type, and it's got the binary type. But just like 20 years ago, there was the open XML function in SQL Server where you could have XML types and you could kind of deep query into an XML fragment. You can do the same thing with open JSON. You can deep query into a structured bit of JSON. Well, now Entity Framework natively supports this. So I can choose with my mapping if I want a collection hanging off of a class to be mapped relationally to a different table in my SQL Server schema, or if I want the entirety of that collection to be serialized into JSON and stored as a JSON document in a particular column in a SQL Server table. Because SQL Server, for several versions, has natively had document type columns and document tables. And now Entity Framework has caught up with the right model to make that seamless for .NET 8 applications. And so once again, if we have different data types, we don't have to have two databases. We can use the full power of SQL Server, regardless if we have document type data or relational data, or very realistically, and most of the time, a mix of the two, depending on what it is. And we can choose how to store it per class and per property with the Entity Framework mappings. So that's really, really interesting. To close up, the good news is that the DevOps environment for .NET 8 applications doesn't change. Some of the steps get simpler when .NET Aspire come out, but it's still the same. We still have to do the 3 steps of continuous integration. We still have to have a minimum of 3 environment types: production, a manual test environment, and a test automation environment. And we still have to have the same process. Thank you so much for your time, and for the people who shot over questions that we were able to work in. Thank you so much. A lot of information. And you guys have a great day and a Merry Christmas. We are back from that pre-recorded piece, and I hope you did have a Merry Christmas, but Happy New Year. Again, welcome to 2024. It's going to be a great year in software. And my friends, until next time, keep shipping.
You've been listening to the Azure DevOps Podcast, a show for developers and DevOps professionals shipping software using Microsoft technologies. Go to www.azuredevops.show for show notes and other episodes. On behalf of your host, Jeffrey Palermo, and our sponsors, thanks for listening, and may God bless you.